Okay. First of all, let me know. Did you go through that recording that I shared in the group? That recording on force moment of force. Raise your hand if you went through the recording. Atika, Hirosh, sorry, Zufar. I think Hirosh. Okay, good. What about Zufar and Atika? Khalid, did you go through the recording that I shared in the group?
Don't allow this.
Zufar, please let me know soon. Just simply you can say yes or no. Because if you have already gone through the recording means, then it will be easy for me. I can do it faster. Didn't you see the group message in the group? I mean, day before yesterday. Yeah, probably on Sunday. I think. Yesterday or maybe day before yesterday. I'm not sure. Okay, I have message in the group that go through the recording. Okay, anyway, I will quickly go through those parts. Okay, so today we will finish it. This moment of force. Okay, so you can write down the topic, moment of force. Okay, so the moment of force is simply the turning effect of a force, right? It is simply the turning effect of a force. For example, if there's a pivot object, it is pivoted to a point, and if you apply a force, it can rotate. That rotation motion is due to the moment of force. Now, in linear motion, in translation motion, which physical quantity responsible for object to accelerate? It is force, right? Likewise, in rotation motion, it will be the moment of force. You will see more on about that in rotation motion lesson. But anyway, so here we only discuss about the basic fundamental uh, theorems in moment of force. Okay, so the turning effect of a force is known as the moment. Okay, so and also here it is also we can call it as torque. The moment of force is also known as TORQUE, torque. So sometimes we usually use the simple, most widely the Greek letter torque. Okay. Okay, so the moment of force you may have already studied in your O-levels that it is given by force times the perpendicular distance. So torque is equals to force times perpendicular distance between the force and the pivot point. Okay, so for example, if you have object like this, and this is the pivot point, so it can rotate about this point, and then you are applying a force, let's say some 20 newtons. Okay, so the torque is force times perpendicular distance. So here first you have to take the line of action of the force. So the line of action will be this. So this is the line of action of the force. And then you draw a perpendicular line to that. So the force F and then perpendicular distance D. Then the torque is given by force into the perpendicular distance. Okay, so this is torque is a vector quantity, right? Now in vectors lesson I have told you, I explained you about the vector cross product. It is not there in our syllabus, but I explain you what is dot cross product to emphasize that whenever you have three physical quantities with three different directions, then all three of them are vectors. So here force is a vector, the displacement, which is the position vector, the d, that is also a vector, and the torque is also a vector. So here torque is equals to force times the distance. So you can see distance is acting in this direction. So it's in this direction, and then force is in this direction, and the torque is from the pivot point coming out of the plane, out of the screen. Okay. So torque is a vector quantity. So since torque is a vector, it has both magnitude and direction. So the magnitude we can find using this formula. So to find the direction, we can use the right hand rule. So you take this right hand, your right hand, and then you have to keep along the distance, and then fold this along the force. Then the torque is given by the direction of the thumb. So this is the right hand rule. Fold this hand, and then the thumb will give the direction of the torque. So if you change the direction of the force, now this is according to this picture here in this screen, it is anti-clockwise. So if you make the force to the other direction, clockwise direction, then the torque will be in the downward. So then if it's plus, we can consider the torque, we can mark it as, so this will make a okay, so here according to this, if I consider the vertical upward as plus, then the anti-clockwise direction is plus. So the torques in the anti-clockwise direction I considered as plus, then torque in the clockwise direction will be minus. There is no restriction like this direction should be plus and this direction should be minus. If you want, you can take the clockwise direction as plus and then counterclockwise direction as minus. That is actually the user's choice. Okay? But whatever it is, now you have to do the max accordingly. Like when you do equations of motion, now you can consider plus as either upward direction or downward direction, like when we are studying about vertical motion under gravity. So if you consider vertical upward direction plus, then downward direction minus. So likewise only here, if you consider the upward is plus, then downward will minus. So upward plus means the what causing the upward, it's the anti-clockwise movement here. So then those are plus. And then if I consider the downward is minus, so downward is clockwise movement. So then they are minus. Okay. It will be clear when we do some examples. We will do it today.
Excuse me, sir.
Yes.
So torque is a vector.
Yeah, torque is a vector. It has both magnitude and direction. Okay. So to find the direction, you can use right hand rule. So fold the four fingers in the direction of the force, and this one you have to keep align the radial direction or in the distance. So the thumb will give the direction of the torque. So there are some applications of torque, right? So when you are removing a bolt, you use big lever, right? So that it will be easy to turn the bolts. It's easy to open and close a door by this far end than closer to this pivoted points, right? Okay, so these are some examples of torque. Okay, so here is an example. Find the torque here quickly. I'll give you a couple of minutes. is equal. Okay, I got an answer. Others also can share your answers. Okay, good. So here we can find the torque. Tau equals force times the perpendicular distance. So the force is 10 Newton and the distance is 0.5 meter. So we get 5 Newton meter. So the unit of the torque is Newton meter. Okay. And what about the dimension of the torque? The dimension of torque, the dimension of torque will be ml squared t minus 2, which has the same dimension as energy and work done. The dimension of torque is ml squared t minus 2, which is the same dimension of uh, energy and work done. Okay. So here the direction is, now I can mark this one causing a, if you take the right hand, it will make a make this clockwise. So you can mark this as clockwise direction. So the direction is clockwise, which means it is into the screen. So it will be inside into the screen, right? So if you consider the into the screen as plus, then other anti-clockwise direction, which is coming out of the screen, will be minus. Okay. Okay, so now we are going to discuss net torque due to a system of forces. So far what we have discussed on torques, which you have already studied in your O-levels, but this is something that is new. I think this also might be there in your O-levels, but I'm not sure. I haven't seen the O-level syllabus. Anyway, so the net torque due to a system of force. So let's say we have here three forces, F1, F2, F3, and they are perpendicular distances D1, D2, D3 respectively. So then here I'm going to consider the anti-clockwise torque. Since torque is a vector, you need to consider a direction. Normally, you don't consider the direction as the direction of the torque. You normally mark it as either anti-clockwise or clockwise. Okay. So here I'm considering the anti-clockwise direction. So that is equals to here F1 D1, F1 times D1. So this F1 D1 product is in the uh, anti-clockwise direction, so it is plus. And this F2 making a clockwise direction torque. So this one, this force is tends this try to rotate this object in this direction, but this one is in the opposite direction, so it will be minus F2 times D2. And then F3 is also in the same direction as counterclockwise, so it is also plus F3 into D3. Okay. So it's a very small thing. I hope you all can understand. If there's anything, you can let me know. Okay. Okay. So the net torque of the system is the algebraic sum of torques of each force of the system. So here we are taking the algebraic sum. Okay. So for torque, it is in Sinhala, it's known as Balagurne, the moment of force, Balagurne. Okay. So the net torque of the system is the algebraic sum of the torques. So now here I have considered the anticlockwise torques are plus, so they are plus, and therefore the counterclockwise torque is minus. Okay. Right. Okay. The next thing is force couple. Force couple means we have two forces. We have two forces acting on an object, equal and opposite. Give me a second. Okay, a force couple means we have two forces acting on an object with the same distance from the pivot point, and also the forces are equal in magnitude and opposite in direction. So here you can see one example when we are turning the what do you call Sukkanam in English, what do you call the I don't know the it's not getting me. If anyone know that word for this, put me in the put it in the chat box. Steering wheel. Okay, thank you. So as you can see, when we turn the steering wheel, if we apply one force in this direction, the equal and opposite force will be in downward direction. Not only steering wheel, by riding a bicycle and opening a tap, right? And more. And we have in magnetic fields, we will study about this the magnetic force acting on a coil of wire. For there also we study this more force couple effect. Okay. So it is a special case of a moment. A better term is force couple or pure moment. Okay. So it is also known as pure moment or force couple. A force couple consists of two parallel forces that are equal in magnitude, opposite in direction, and do not share the same line of action. Okay, so you can write this down quickly. Okay. A force couple consists of two parallel forces that are equal in magnitude, opposite in direction, and do not share the same line of action. So if it has the same line of action means, then there wouldn't be a force couple. For example, let's say one force is acting in this direction. Okay, then the other force also acting in that same line of action. Then they will cancel each other, so there won't be a force couple, and in fact there is a net zero moment of force, right? The moment of force also will be zero. Okay, so it should not share the same line of action, but rather it can be like this also. Okay. It not necessarily has to be in the two sides of the pivot point. Both can be one side of the pivot point. That is also fine. But if you consider both at one side, then the distance will not be the same. So then, no, it won't be a force couple. Right? Then it won't be a force couple. So therefore, it has to be a other side.
So the forces have to be parallel
Yeah,
to
force
each other.
has to be parallel. They must be parallel to each other. So it says opposite in direction, right? So opposite in direction means angle is 180 degrees. So one is in this direction, the other one is 180 degrees means it will be parallel, no? Definitely, right? So they are parallel. So a force couple consists of two parallel forces that are equal in magnitude, opposite in direction. So if in a question, if a question asks you what is a force couple, then you can say two forces which are parallel to each other, equal in magnitude, opposite in direction. Okay. Okay. So a force couple has a resultant moment, but no resultant force, because you can see the force are equal in opposite direction. So it does not accelerate, right? The resultant is zero. Now, for example, when you're opening a tap, the tap doesn't move, right? Because if there is a unbalanced force, okay, then it will accelerate in that direction, or it will at least feel some thrust force on it, right? But since it is equal and opposite, both the forces are it will cancels off each other, so the resultant is zero. Okay. So the force couple does not produce any translation, only rotation. It does not produce a translation force, only a rotational force. So here are some examples for force couples. So also know any acceleration of the center of mass. Okay, the center of mass remains unchanged. So if, for example, if you consider this, the center of mass, since this is a circular shape, the center of mass would be at the center. So the center point does not change, right? Okay. So now let's try to calculate the moment of a force couple. Okay. So we are going to now calculate the moment of a force couple. I'll quickly do this part. So here you can consider any point. So for example, I consider this point, let's say. First of all, I take the distance between these two as the perpendicular distance. You may have studied in your O-levels. The distance between two parallel lines means you have to draw the perpendicular line. Okay. So let's say this distance is simple d. Okay. The distance between these two forces is simple d. So now I'm going to consider 3 points. I'm going to consider 3 points. So one point is here, another point is here, another point is here. Any 3 points. So A, B, and C. Now I'm going to find the moment of force about these 3 points. Okay. So let us try to find from A to A. So I have marked tau A because I'm finding the moment about the point A. Okay, so from point A, now let's say I take this distance as x. Okay, so I'm taking clockwise direction. So this f is making, this one is making a clockwise movement. So that is f into x. And but this one, that is also making a clockwise movement. Okay, so that is also plus f into. So now this distance x, therefore this distance will be d minus x, right? If the distance between the two lines are 10 centimeter, if this is 4 centimeter, then this will be 6 centimeter. Likewise, since this is x, therefore this is d minus x. So therefore the distance d minus x. So now let's simplify this, fx plus fd minus fx. So minus fx plus fx cancel, we get fd. Okay, and then now I'm going to take the moment about the point B. So B, you can consider any direction, clockwise direction or counterclockwise direction. So here I consider the counterclockwise direction, for example, let's say. Okay. So then here, this one making an anti-clockwise direction. So that is okay. So here I take this distance as the perpendicular distance. I will take as y. Okay. So then therefore the moment due to this force will be f into y. Okay, and then this one is making a counterclockwise moment, so it's minus f into the distance is d plus y from this point, from point B, the distance, perpendicular distance is d plus y. So therefore this is equals to fy minus fd minus fy. So plus fy and minus fy cancel. So here we get minus fd. So that is tau b in counterclockwise direction is minus, which means in the opposite direction it will be plus. So again we get the same value and direction. Here also clockwise direction fd, clockwise direction fd. Now let's try to find from point C to C. I consider the counterclockwise direction. Okay, and let's take this perpendicular distance as z. Okay, then this force F is making counterclockwise, because from this point it will making, trying to rotate in the counterclockwise direction. So it is plus Fd. And this one is in the clockwise direction, so it's minus. The perpendicular distance is, sorry, that is Fz, should be Fz. And then this is d plus z. So then we have Fz minus Fd minus Fz. So plus Fz minus Fz cancel, we get minus Fd, which means the net torque is in the counterclockwise direction, sorry, clockwise direction, about point C, Fd. So you can see, regardless the point, you can take any point. So the moment of force will be the same value. So you can put a note, the star, and write the moment of force of a force couple is same from any point on the plane, any is same from, can someone read? I missed it. Okay, I'll read it again. The moment of a force couple is same on any point on the plane that consists the two forces. Same at any point on the plane that consists the two forces. Now we have these two forces now. So if these two forces are in this direction, then there is a plane that spans contains these two parallel forces. So on that plane, you can take the movement from any point. It will be the same. That is given by F into D. Okay. Suppose if these two forces are in this way, this one is this direction and this is this direction. So you can see then it will be anti-clockwise movement. Then the movement will be in the anti-clockwise direction. Okay. You can take a screenshot. Okay. The net moment of force or the net torque. Net torque. The net torque of a coplanar forces. Coplanar forces means all the forces are lying on the same plane. Okay. The net torque of a coplanar forces about any point on the plane is equal to the torque of the resultant force about the same point. Okay. Now here we have three forces F1, F2 and F3. And in previous lesson, I mean in vectors and all, we studied how to find the resultant vector. So since these are forces, we can find the resultant force. So let's say the resultant force is given by this one. Let's say this is the resultant force. Yeah. So let's say this is the resultant force R. So in vector notation, I can write R is the sum of F1 vector plus F2 vector plus F3 vector, resultant of F1, F2 plus F3. Okay. So here it says the net torque of a coplanar forces. So we have F1, F2, F3, and previously we studied how to find the net torque. So for example, if you want to find the net torque about the point O, then tau O, the torque about point O in the counterclockwise direction is equals to F1 D1 minus F2 D2 plus F3 D3. So this is the net torque, right? Because you take the previously studied the net torque is the net moment of force is the algebraic sum of the moment of forces of due to each forces about the pivot point. Okay. So this is the net torque. Okay, and then it says the net torque of a coplanar forces about any point on the plane. So it is not necessarily the pivotal point. Now, for example, if you have object, there is no pivotal point. Okay, and then there are three forces acting on it. Okay, so you can consider from any point. Even if you want, you can take from this point also from A, but the thing is you should know the perpendicular distance to these forces from that point. That is the important thing. You should be knowing the perpendicular distances to those forces. Otherwise, you can't take this point A. Now, since they have given D1, D2, D3, so I can simply take this point. Okay. So you can take the movement from any point if you know the perpendicular distances. Okay, right. Since here now the net torque is given by this. Okay, so it says the net torque of a coplanar forces about any point on the plane is equal to the torque of the resultant force above the same point. So now this is the resultant force. Then you have to take the perpendicular distance to that force from the same point. So let's say that is D. Then I can write, so this is equals to R times D. So R is the magnitude of the resultant force vector, R times D. Okay, so since we can see the resultant is also making a counterclockwise direction, therefore this is correct. Now suppose if I take this as this direction, let's say, yeah, in this direction, so F1 D1, so then this I had to write in minus, so counterclockwise direction I'm considering, so minus F1 D1 plus F2 D2 minus F3 D3 is equals to, now this one I'm considering the clockwise direction, but the resultant is making counterclockwise direction, so minus R times D. Okay, raise your hand if you understand clearly this part. Atika, Bhushani, Hirosh, Khalid, Zufar. Please raise your hand. What about Atika, Bhushani, Khalid? Atika, okay, good. Bhushani, Khalid. Khalid, did you understand? Okay. So that is the net moment of force. Okay. This is very important. Now in equilibrium lesson and all, we have to use this in mechanics and in rotational motion and all. Okay. You can take a screenshot if you want to know this. Okay, the principle of moments or the principle of moment of force. Okay, the principle of moment states that when a body is in balanced or equilibrium, the total clockwise moment about a point equals to the total anticlockwise moment about the same point. Now let's say here. Okay, now let's say the object is balanced. Object is in equilibrium. If we take object, that object has two types of equilibrium or two types of motion. So first I will talk about two types of motion. One is translation motion. Okay, actually three types of motions are there. Okay, so translation motion. If you take object, it's only move. Okay, so its position changes, displacement changes. So that is translation motion. And the other one is rotation motion. The center of mass doesn't change and it will rotate. And then we have the combined motion where it is translate and rotate. Okay. Now, likewise, now when it comes to the unbalanced force or the acceleration, the unbalanced force causes acceleration. So the unbalanced force makes a linear acceleration. The velocity increases. Okay. The quantity which is needed to change the state of motion is the force. Force is the physical quantity which requires to change the state of motion or change the velocity of the object. So likewise, in rotation motion, the quantity required to change the angular acceleration, okay, is the torque. Because just because of the force is there, it won't rotate. Now, for example, let's say he is an object and this is the pivot point. Okay, that's fixed. So if force is acting along that pivot point, then if the force is acting along that pivot point, then that object won't rotate. Or you have an object, if you have object and then you are applying a force through the center of mass. So after the talk, we will start center of mass, center of gravity, and equilibrium, those sessions. Then it will be more clear what is center of mass means. Okay. So when we apply this object, if you apply the force to the center of mass, it won't rotate. But any further from the center of mass, then it will cause a rotation motion also, because there will be a movement of force. So in order to have a rotation, gain a rotational velocity, now object is rest and they want to accelerate in rotationally, then you have to apply a torque. Just because of force is there, we can't say object will rotate. So if the torque is zero, see, so here you can find, but in this one, so the torque will be zero. Force times perpendicular distance is zero, so it won't rotate. Okay. So that is about the acceleration. Now, force causes linear acceleration, and the torque causes rotational acceleration. Now, for a fun, I can modify Newton's first law for rotation motion. Such thing is actually not there. You don't study or anything, know any books there, but still I can modify for a fun for the rotation motion. The Newton's first law, how can I modify it? Unless an unbalanced external torque is applied, the object is at rest, remains at rest, or object in constant rotation motion remains at that constant rotational velocity, or we call it angular velocity. That rotational velocity is angular velocity. Okay, such thing is not there, right? I'm just but it is true. Okay, it is true. Okay, and also you can modify Newton's second law also for the rotation motion. The net torque acting on an object is directly proportional to its rate of change of angular momentum. Okay. Okay. Fine. By the way, okay, so that is about acceleration kind of stuff. Okay, now when it comes to equilibrium, so then equilibrium also there are two types. One is translation, linear equilibrium. So if the two forces are balanced. Now, for example, if you take force couple, that is translational equilibrium, because its center of mass doesn't move, right? Because net force is zero, so it won't move. Okay, so for example, now if I take this, so it's in equilibrium. The gravitation force acting vertically downward, normal reaction force acting vertically upward. So forces are balanced, so they are in equilibrium. Okay. Now also this is in translational equilibrium. Okay. Because I can see this is not rotating, right? This is not rotating. So this is also in rotational equilibrium. Okay. Or if it's moving at constant velocity also, it will be in equilibrium. We say an object is equilibrium if the forces are balanced. Okay, so according to Newton's first law, if the forces are balanced, the object can be either remains stationary, remains at rest, or moves at constant velocity. Okay, now I think if the net force is zero of object, the object remains stationary. I mean, it's equilibrium. So that thing very fundamental, you all can understand, right? Okay, but now here when we come to the rotational motion, torque and kind of stuff, so the object is equilibrium means the net torque has to be zero. Net torque, T net, rho net should be zero. Okay, if the object is in equilibrium means the net torque must be zero. Okay, did you all understand that? I mean this, if object is in equilibrium. object is in rotational equilibrium, then net torque has to be 0. Please let me know in the chat box if you understood. Say yes, otherwise no.
No, sir.
Okay, I'll explain. Okay. Okay, so the torque is the physical quantity which causes an object rotate. So now you can see if the net torque is 0 means an object won't rotate, right? If you want to rotate an object, you should have a torque, non-zero torque, right? Now here we are saying if object is in rotational equilibrium, that means if it's not moving, then net torque has to be 0. The net moment of force has to be 0. Understood? Okay, did you understand? Okay, good. Okay, so now here when you come to take for this example, now here we are taking the torque about the uh, point O. So I take this equation. So it says F1 D1 minus F2 D2 plus F3 D3, right? So if the object is in equilibrium, the net torque has to be 0, right? Net torque has to be 0. So now what you can do is you can take the minus terms to the other side. So these are minus, this one is minus. So let's say there is another force F4 acting again in clockwise direction, then that will also will be minus F4 D4 will come, right? So then you will have F1 D1 plus F3 D3 is equals to F1 D1, because if you take the minus terms to the other side, it will be uh, plus. So it is F2 D2 plus, now let's say there is another force F4 acting in clockwise direction is F4 and the perpendicular distance D4. So then I have included that also, then it is comes to this side F4 D4. Now what is this? This is the sum of clockwise movement. So tau O clockwise is equals to tau F1 D1, sorry, anti-clockwise. So this anti-clockwise movement is equals to tau naught clockwise. So this is the principle of movement of forces. If an object is equilibrium, the net for anti-clockwise movement is equals to net clockwise movement. So here the principle of movement states that when a body is balanced or in equilibrium, the total clockwise movement about a point equals to the total anti-clockwise movement about the same point. Okay. So if you are taking the clockwise movement about point O, one particular point, then you have to take the anti-clockwise movement about that same point. So if the object is balanced, so then its net torque will be 0. Okay. Okay, so by the way, here we can say one more thing. Now here, according to this equation, according to this theorem, the net torque of a coplanar forces about any point on the plane is equal to the torque of the resultant force about the same point. So if it's balanced means, then the R into D must be 0. That means either R should be equal to 0 or, so this is what you have studied in your O levels. Like if the product is equal to 0, then R is equal to 0 or D is equal to 0. That means the resultant might be 0. We can't say definitely resultant is 0, right? Just because of the net movement is 0, you can't say the resultant is 0, because still you can have a resultant, but the moment about that point O will be 0, meaning that R is acting through the resultant of these force are acting through the point that you have considered.
Excuse me, sir.
Did you understand? Yes.
So how do you calculate the resultant force?
Resultant force that we can we start. I think you. I don't know. You have studied the resultant vectors and all.
We use
Like
that, sir.
if you have two parallel forces, then you know simply add. If they are opposite, you subtract.
Okay, okay.
If two
Okay, sir.
perpendicular means you can use Pythagoras theorem. Or if two forces making angle means, or else if you have system of forces, you can resolve into two components, perpendicular and vertical components, and then separately you can find the resultant in horizontal components, and then find the resultant of vertical components, and they will be perpendicular to each other, and then you can use the Pythagoras theorem to find the magnitude of the resultant, right?
Okay, sir. So
So
you're saying
about
that F1, F2, and F3 they cancel each other out?
no, actually here, if the object is equilibrium, then net torque is 0. That means clockwise movements is equals to counterclockwise movement. Now, for example, let's say there is a merry-go-round, you are pushing with one force, 100 Newton, and your friend also pushing in the opposite direction uh, with the same 100 Newton. Then it won't rotate, it is in equilibrium, right? But now you are applying 100 Newton, but your friend is applying 50 Newton. Let's say you are applying in clockwise direction, he is in anti-clockwise direction. Since your movement is large, it will accelerate rotationally. Rotational acceleration will be there. Angular acceleration will be there. Okay. But if our object is equilibrium means, then counterclockwise movements, the net counterclockwise movement is equals to net clockwise movement. Okay. So meaning that the net movement, the object is 0. Okay. Okay, so here, if the net torque is 0, we can't say the resultant is 0. Resultant can have a non-zero value. That means the perpendicular distance to that resultant from that point that we have considered will be 0. Okay. Now regarding the resultant force, we know how to find the resultant force, right? We know everything about the resultant force, how to find the resultant force of two parallel forces which are in the same direction and which are in opposite direction, and two perpendicular force, and the system of forces. For all of this, we know how to find the resultant and the direction of the resultant vector, resultant force. But the only thing we don't know is the line of action, how to find the line of action of the resultant force. Now, for example, let's say we have an object, for example, let's say a box. Let's say we have a box. Okay. And let's say there are two forces acting on it. This one and this one. Let's say this is, for example, 40 Newton. This is 30 Newton. And to find the resultant, it is easy. The resultant of these two will be, so I'll mark, draw in the different color. So the resultant of these two forces will be let's say 70 Newton. Okay, so the resultant is 70 Newton. That is very easy now, since both have the same direction, you have to add. But the only thing we don't know yet, where is this force acting? Is it here or here, or I mean the resultant? So we don't know where is the line of action of the resultant force. Okay, so that is another concept that we will study under the movement of forces. We can use the principles of movement of forces to find the exact location of the resultant. Okay, probably by today or maybe in the next class, we can study about it. I hope if the time allows, we can study about it today. Okay, yeah, probably we can start today. Yeah, I think. Yeah, if you, yeah. Okay, so in fact, our next topic is that. By the way, before going to that, I want you all to do some questions. Let me share you that. Okay, guys, I have some questions for you. You need to find the moment about here point O. I'll give you a couple of minutes. You can share your work if you have finished. Give me a second. Okay, quickly do these questions.
Excuse me, sir. Excuse me, sir.
Yes. Yeah.
Uh, sir, I'm done, sir.
Okay, can you share your working? You
Okay.
can send it through Zoom chat to TKI. Okay, I got answers from Hiroshi as well. First one correct. Second one, 9. Okay, correct. Third one correct. Fourth one, mm, mm, okay. Also, you have to mention the direction, either clockwise or anti-clockwise. Okay, good. Okay, I will give the answers. Check whether your answers are correct. Okay, so the first one, so in the first one we have anti-clockwise. Tau equals the anti-clockwise 4 into 3. Let's say tau O, about point O. So it is 12 Newton meter into the anti-clockwise direction. Okay, good. Uh, so the B we have in the clockwise direction. So 9 into 1.5. So 9 plus 4.5, 13.5. That is also that is clockwise direction. So here net torque is 0, about 0.0. And here we have consider the clockwise direction. From 0.0. So I can mark like this also. Like you just put the letter and indicate the direction. Okay. So here 5 into 3 plus 4 into 1 minus 6 into 2. So 15 plus 4, 19, 19 minus 12, 7 Newton meter. Okay. So these are pretty easy. So let's do more questions. Okay. You can take a screenshot of this. You can do it as homework. Okay, do these questions starting from question number 7 to 7, 8, 9, 10. Yeah, no. Do question number 7, 8, 9, 10. 7 also, maybe you can do it as homework. It is also much easy. It's also simple. You have to find the moment about point O in each of these. Okay? Point A in each of these. So do it. Do 8, 9, 10. Now, meanwhile, I will pleasurely have some water and anyone finish with question 8? You may can send your answer. All the morning as it's always there, Benjamin. Clockwise. Yeah, correct. Your answer is correct. It's simple. First, you have to think, find, identify. First, you have to identify whether the force is clockwise or anti-clockwise. And then, if it has a clockwise moment, then you have to take force times the perpendicular distance, right? So, if there are two moment of forces, then accordingly you can take their arithmetic, then sum, arithmetic sum. Okay. So check your answer whether your answer correct. Uh, okay. Have you heard of string theory? Yeah, string theory is one of the theories that tries to unify all the theories in physics, theory of everything. So far the scientist has unified. Now, for example, if we take the universe, they are made up of particles and the particles of forces. So which both together we can call it a standard model. Say that standard model. So this is there in your 10th unit under the particle physics. Right? You have some introduction for particle physics. So there you study about this standard model, quarks, leptons, antiquarks, antiparticles, those things. So, and here also you study the 4 particles that corresponds to the interactions. Now, there are mainly 4 types of forces in the universe. So, one is electromagnetic force. Electromagnetic force. So, electric force you have already studied, right? Electrostatic force, and also the current dynamic also it's comes under this electromagnetic. So electromagnetic force means electric force and magnetic force both combined together, we call it electromagnetic force. So the electricity and all comes under this electricity, electrostatic force, magnetic force, all comes under this. Even the friction is due to the, it is also electromagnetic, it's an electrostatic force between the surfaces. Okay, so almost, I mean, in our day-to-day life, most of the forces comes under electromagnetic force. Okay, friction and electricity, electric force, magnetic force, and many other. Okay, and then the other one is gravitational force, gravitational force. And then we have strong nuclear force. Often it is also called as nuclear force or strong nuclear force. So which is responsible for keeping the nucleus bond together. Okay, it binds the nucleons. I mean the neutrons and protons. Now, for example, if you take a helium atom, it has 2 protons and 2 neutrons. 2 neutrons are neutral, but protons have positive charges. In electrostatic lesson, you have studied that same charges repels. Then what keeps these 2 protons bound together without the repulsion? There is definitely a repulsion force is there, but there is another force that overcomes that repulsion to keep that 2 protons stick together. So that is strong nuclear force. During this atomic bomb and all, this strong nuclear force is the strongest force in the universe. So there are 4 fundamental forces. So out of these 4 forces, the nuclear force is the strongest force. But its the range is very small in the range of nucleus of atom. Okay. Now, for example, in atom bomb, nuclear bomb and all, for this interaction, it has large force, so their potential energy is only released as thermal energy. Okay, and then finally we have strong nuclear force and then weak nuclear force. So which is responsible for decay reactions. When unstable nuclear will decay and emitting radiation. So for this decay process, this weak nuclear force is only the responsible, right? So out of these 4 forces, the strong nuclear force is the strongest, and the weakest one is gravitational force. The gravitational force is very weak because you study in the gravitation field lesson that G constant is 6.0. I'm not sure about the magnitude, the value, but it's in the range of 10 to the power minus 11. Okay, so that is very small. So out of these 4 forces, gravitational force is very small, very weak. So, but anyway, about the theory of everything. So far, the scientist has unified, that means combined this electromagnetic, strong nuclear force and weak nuclear force together, right? But gravity is not included there. Still scientists are working. So it's actually a theoretical physics framework. This comes under theoretical physics, but if you want to make it proof, you had to come to practical experimental physics, right? If you if the theory is proved only in science, you have a theory, then it has to be proven. You should prove. So how do you prove? It's in the experiments. So anyway, so far the scientist has combined these three forces together, okay, and all the other particles in the standard module. So for these interactions also we can assign a particle. We call it bosons, right? So the boson of electromagnetic force is the photon, the intra force carrier photon, and this for graviton. So graviton is only theoretical; it's not uh, experimentally detected. The strong nuclear force, gluon, and for this W is at bosons. Okay. Anyway, so far scientists has combined these three forces, but not the gravitational force, because it is so difficult, because the gravitational force is the weakest. So very advanced detecting machines, because the gravitational force is very small. So therefore, still the scientist has not combined gravity. So we call this problem as the greatest problem in the physics. So if you can combine gravity with all the forces, then you will definitely get the 100% sure you will get the Nobel Prize. You will become a scientist like Newton and Einstein. Okay. So this problem is known as quantum gravity, problem of quantum gravity or theory of everything, because these three forces are combined using quantum theory, quantum mechanics. So all these three are explained in the quantum theory. In fact, quantum field theory. So quantum mechanics is one. If you go higher level, quantum field theory, which is the most accurate theory of the universe. So now scientists are trying to combine the quantum field theory and gravity. Okay, so this problem is theory of everything. Theory of everything means we want one theory which explains everything in the universe, right? So so now the candidates are string theory and also M theory. So string theory, now according to quantum field theory, now these things are not there in the syllabus. Even I didn't have any idea about this until I finished my A levels, and yeah, after the A level only I had some free time. So those time only I was going through these documentary videos in YouTube and stuff. Okay, so this, according to the quantum field theory, all the particles are made of vibrations in each field. Now, in the last lesson, you will study quantum physics. In quantum physics, in the quantum realm, in the subatomic level, particles behave as waves, waves behave as particles. So particles behave as waves, so therefore it can has waves. So all the particles have a wave nature or field. Now electromagnetic waves is also a wave. So it has a vibrating electric field and magnetic field. So the quantum field theory is all the particles and all the forces, everything made of these fields, vibrating waves. Okay, but still they didn't combine gravity into that, because gravity is more small. So that is it. So string theory is one candidate. So string theory, it combines the gravity is also, but the problem of string theory is it requires higher dimensions. Earlier it needed 23 dimensions. Now I think they have in the theoretical framework they have done some more, and it is has limited to 11 dimensions. But still they are theoretical, not proven. Okay. So string theories means now all the particles and everything are made of vibrating strings. Anyway, so those are not in our syllabus. Okay. Since he asked me an interesting question, I couldn't resist myself without not to answer. Okay then. So I hope you have finished these questions. So I'll give you the answers. So in the question number 8, the 2 Newton force is the line of force is going through the point A. So the torque due to that will be 0, but this 4 Newton makes a anti-clockwise torque about point A. So 4 into 3, so 12 Newton meters. So now here in this question number 9, we have torque about point A due to 4 meter in the clockwise direction. 4 into perpendicular distance is 3. So 4 into 3. And then this 2 Newton also making a clockwise. The perpendicular distance will be, this distance is this one, 1 meter into 1. So 4 into 3 is 12, 12 plus 2, 14 Newton meter. And here in the question 10, the 4 Newton makes a clockwise torque, so 4 into 3, but the 2 Newton makes anti-clockwise, so it is 2 into the perpendicular distance is 1, so 12 minus 2 is 10 Newton meter. Okay, I hope it is clear. You know what, in our A-level syllabus, it's only a foundation for the physics, because you study only the basic things. Yeah, I'm serious. Now, for example, if I give you grade 8 max paper, can you do it? You will take definitely 100 out of 100. Or at least, you will take somewhere around 95 to 100. Grade 8 max paper, right? Okay. But at that time, when you are sitting for your exam, third term exam of grade 8, then it is like a big deal for you, right? So like that only, when you advance yourself higher and higher, the previous things feels like basic. Okay. Okay. According to Einstein, gravity is not a force, right? Yeah, gravity is not a force, it's the fabric of space-time. So here Khalid has asked a question, what is learned dimensions? So actually, okay, I'll ask you all one question. We humans or animals, are we are which dimensional being, or one dimension or two dimensional or three dimensional? Yeah, we are three dimension. We have volume. If it has only a surface, it's two dimension. We have a volume also. We are three dimension. Okay. The next question. We are living in the universe. It has how many dimensions? The universe that we are living in. No. Guys, you can take a screenshot. Also, you can try some questions. But again, I will leave it this as homework. Okay. Yeah, so four dimensions. We are living in four dimensions. Because now, for example, here I have a pen, which is I kept on the table. So let's say that's the table I had kept here. Okay. So to give these coordinates, I need 3 points. The length, so x coordinate, y coordinate, z coordinate. So Michara, you had to go 3 meters to the left and 2 meters to front or forward, and then 1 meter vertically upward. So we need to give the location in the space. We had to give 3 coordinates, so 3 dimensions. Now this pen is here. and now the pen is not there because we are living in 4 dimensions. So the fourth dimension is the time. So if you want to give the specific location of this, or for example, someone is having a wedding ceremony. If they are inviting you, if they give the only the venue, is it enough? They should mention the time also, no? Dinner. Okay. We have a dinner, come and eat and go. Right. So if the time is not mentioned there, so they may be arranged for the lunch and then they all done eat and go on. You are going for the dinner, assume it's dinner. So no one is there. illa inna mess ටික බලලා ආයි හැරලා තමයි තියෙන්නේ. Okay. So therefore the time also should be there. Okay. So therefore we are living in a 4-dimensional universe. Okay. If you want to understand higher dimensions, we can't imagine or illustrate or think about the higher dimensions. Since we are 3-dimensional being, we can't so we are living in a 4-dimensional world. We can't experience or think or imagine how it looked like in 5th dimension universe. Okay, the fifth dimension also parallelly can exist with us. If you have watched Interstellar movie, there's a glimpse of idea. It's there. Okay, if you want to understand higher dimensions, you need to study the lower dimensions. So there is a book called Flatland. It's about 2-dimensional beings. So if you go into that, then you can understand how these flatlanders experience the 3-dimensional world, how these 2-dimensional beings experience 3-dimensional world. With that, we can also think, okay, then 4th dimension also like this only. Okay. Now 5th dimension beings can interfere our universe, but we can't observe or detect the 5th dimensional beings. Okay, these are all like big physics are all theoretical. According to maths, it's completely true because everything is maths. Okay, I think you may have seen the picture of tesseract, which is a cube in 4 dimension. Anyway, those things apart. Okay, so I think you can do this question, these questions, right? So I'll leave it to you as homework because I need to discuss one more theory, the last theory of this moment of force, which is how to find the line of action of reaction force. So you can take a screenshot of this also, so you can find the moment. Okay, actually my ambition is to become a theoretical physicist. Okay, actually if the corona is not there, were not there, I wouldn't be here because my plan was after completing my MSc to go abroad and study, do my PhD, either America or Australia. So that was my plan. But due to this pandemic, corona thing came. So my the MSc program was only 1.5 year. So I thought of after 1.5 year I can go to abroad and do my PhD. But so due to the corona, the coursework, 1 year coursework dragged to more than 3 years. So with that and parallelly, my parents passed away, and then also I started an institute, and then the other commitments, and I had to take care, look after my sister and all those things. Then all things like not according to the plan because of this corona thing. Otherwise, I might have already completed my master's and research work completed, done. Now I'll be doing some PhD in university actually. Okay, then, so here you can take a screenshot of this also. Here you have to find the moment of force about each point A, B, C, and D. Take a screenshot and please do this question and send it to me through WhatsApp before our next class. Before our next class means, which is day after tomorrow, right? So please make sure. Thank you. Thank you. You know, I have a lot of dreams, like I want to have innovation. I love innovations, new innovations. I would like to create a place where the minds with new innovations gather one place and do some project, something like that, and all. Those are my dreams, but now I'm financially um, in a struggle because Hirosh might know I told last time I was doing an institute and then it's completely lost, and I had a debt of 1.5 million. Now I have reduced to 11 million. So until I finish this debt, I can't even promote my classes for the marketing and all, because whatever I earning is going to uh, repay that. So anyway, please include me in your valuable prayers. Your prayers can change things. Okay. So here you have to find the moment of force about each point. So for example, I will consider from point A. Okay. So I'll do it as an example. So when we take in the moment about point A, so this force and this force won't come because it is going through uh, the point A is in the line of force of those two forces, but this and this we can consider. So I consider clockwise. So we have 4 Newton, and then the distance is 2 meter. So it's a all same length, have 2 meter. Minus this 2 Newton times perpendicular distance is again 2 meter. So 4 minus 2, 2 into 2, 4 Newton meter. Okay. Since okay, I'll give you some shortcut. If the perpendicular distance are same, you can take the subtract the forces 4 minus 2 and then multiply by the distance. Okay. That thing you can do only if the perpendicular distance are same. For example, let's say you have a sphere, and then you have some forces acting on it, and then radius of the sphere, say 2 meter. So then here you can take the algebraic sum of these forces. So here 4, and let's say this 2 and 3, 5. So here these 3 are anti-clockwise. So 3 into 5, 9. 9 minus 5, 4. 4 into 2, 8. So therefore 8 Newton meter will be the resultant torque. Okay. This can be done only if the perpendicular distance are same. Okay. Okay. So now the others you can do as homework. I love to become theoretical physics because mathematics. Now, if you study higher physics and all, the maths will mesmerize you. Now, for example, in my university, I studied linear algebra, right? So it's like very abstract. Like now, A level, we do like lot of questions, integration, calculations. So in my life, my A level is the time where my IQ is so high, because those time we do lot of questions. Like in combined maths, we had to do many questions, right? So they are very, very tough and very interesting. But when you go to university, the questions are not so hard like that. So they are like easy questions, abstract and all. So this linear algebra, that is also very abstract. Now I was wondering, ඉවලෝ කස්ටපට මෙච්චර අමාරු වෙලා ඉගෙනගෙන කැම්පස් ඇවිල්ලා මේක ඉගෙන ගන්න ඕනේ නේද? Like it says you have like orthogonality, basis vector, if this is a solution, A is solution, this one is, it's like reading boring storybook, abstract maths. Okay, so I'm wondering, so after I finish my university, if I go to a work, how these and all helpful for me? Why I'm studying this kind of nonsense? That is what was there in my mind when I was studying those lessons. So after my university time period is over, I told you I go through these YouTube videos and all, and then you can find complete like 2 million, 3 million courses entirely free in YouTube, MIT Open Courseware. You can search MIT Open Courseware, quantum physics, and a lot of things like financial marketing management, everything full course is they have uploaded. Okay, so I was going through these videos and also referring books and all. Then I realized, oh my god, so the quantum physics means it's only a mathematics. It's an application of this linear algebra, the superposition, which is leads to superposition of electrons. It can be any place, and also it leading to parallel universe theories and all. Mind blowing. It's all comes from the max matrices, linear algebra, everything. If you want to expert in max, you want to study linear algebra. Anyway, okay, so let's move on. Okay, so write down the topic. Hiroshi also can write, because this part is not there in the recording, the line of action of a resultant force. Hiroshi, which group me, I mean, which group you are talking about? Okay, I'll check after the class. You mean, okay, there are actually 3 groups for 2026 theory students. One is B1, which is you are there, that group I started when I was teaching at Sigma. So that group. Then the other one is B2, the after results batch, and then there is a 2026 council. So all students from 2026 joined into that group. So out of these two, let me know which group you are referring. So I'll check, can add you there. Okay. Okay, so the line of action of resultant force. So under that subtopic, 2 forces are in the same direction. Write down this. Okay, I'll share the homeworks that these things to the group. And sorry, it was supposed to be, okay, yeah, these things. Okay. Yosh, super. Zufar, doing biology or combined maths?
Combined.
Bio. Okay, and what about Khalid? Combined, okay. Khalid? Khalid, you are doing bio or combined? Max. Oh, okay. So all of you combine max. Okay. So here this part that we are going to study, this one, you had to use more. I mean, mainly in equilibrium lesson, and also find the result and force the line of action and all. So for the combined max students also has to use that in many lessons, equilibrium, and then friction. So in applied, you have to use this. Okay. So here, let's say we have two forces in first one. They are in two forces are in the same direction. Okay. So let's say there are two forces acting in same direction. Okay. Let's say the two forces are F1 and F2. Okay. And now we want to find their resultant. So since both the vectors are in the same direction, since both F1 and F2 are in the same direction, we can write R, which is the resultant, is equals to F1 plus F2. So that is the addition of the vectors, in fact. So R, the magnitude is equals to F1 plus F2. Okay. Even if the F2 is in the other direction, the resultant we write as R equals F1 plus F2. So addition of two vectors means finding their resultant. Okay. Okay. Since the two vectors are in the same direction, we can write R equals F1 plus F2. So now we know how to find the magnitude and the direction. Since R will be in the direction of F1 or F2. Thus they are in the same parallel, the direction will be the same. Okay. So the magnitude we know and also the direction. So the direction of the resultant will be in the same direction of F1 and F2. Okay. Now we know magnitude and direction, but the one thing is missing, where it is acting. Okay, the line of action. So that's what now we are going to find. Since I know R will be in the same direction, so I will draw a parallel line and I will mark that as R, resultant vector. So then we can find the line of action considering this. Okay, that fact that the net torque about any point on the plane that consists in two forces is equals to the torque about the same point by the resultant. Okay, so now I assume that the line of action of the resultant is going through here. It can be here, or it can be here, right? Let's assume it is here. Okay. So I take this length as x and this length. So the length between two lines is actually the perpendicular length. Okay. So whenever I say, you should understand that. Okay. So here y. Okay. Now I consider a point on the line here. Let's say O or as capital A. Okay. So I take the movement. You can take either clockwise movement or anti-clockwise movement. So I take clockwise movement about A. So the F1 makes clockwise movement F1 times X. But this one is making anti-clockwise opposite direction. So minus F2 times Y. This is equals to R times the perpendicular distance, let's say D. But we can see we have taken the point A on the line of action of R. Therefore, the D is 0, perpendicular distance is 0. Okay. So then we get F1x minus F2y equals to 0. So therefore, F1x equals to F2y. Okay. So if we know the distance between F1 and F2, since here we have two unknown values, x and y. So we need another equation to solve the system, right? In linear algebra. Now I told you I studied in A level and university linear algebra. So in linear algebra, you will study this. If you have a linear equation, let's say ax plus b equals to c. This system is solvable because you can solve and find the value of x. X is the variable, a, b, c are constant. But if you have something like this, ax plus by equals to some constant. Now you can't solve this, right? Because if you want to find the solutions, then you should have another equation. If you want to solve a variable with equation with one variable, then you should have at least one equation. Two variables, then you should have two simultaneous equations. Three means three simultaneous equations. So these things you study in linear algebra. Okay. So now we have two unknowns, but we have only one equation. Suppose if you know the distance between the two forces, let's say something like simple A, the distance between these two. So then we can write another equation, x plus y equals to A. Then you can solve this and find the value of x and y. Or else if you don't know this, suppose if you don't know the length between these two, what you can find is, you can find the relative position. Now suppose, let's say F1 is, okay, so example 1. If F1 equals 10 Newton and F2 also equals 10 Newton, then what you get? F1 over F2 equals to y divided by, F1, yeah, y divided by x. So y divided by x is equals to y divided by x is equals to 1. That means the length y and x has to be 1, which tells that the reaction force, resultant force will be at the middle. Okay, so you can find the relative position. Okay, another example. So this says, therefore, the line of action, of the resultant of F1 and F2 will be at the middle. Okay. Another example too, if let's say F1 is equals to 25 Newton and F2 equals 100 Newton. So if y over x, y divided by x equals F1 over F2. So you get 25 divided by 100, so 1 over 4. So the relative position y is 1 to 4 ratio. So therefore this one will be here. The y length is 1 and this length is 4 times that. 1 to 4. Can you all understand that? Is that clear, guys? Please let me know if you understand. Means it's easy so that the other parts also, the part B and C also similar. Okay. So therefore we can use this theorem about the moment of force to find the line of action of the resultant force. Right? The theorem, what is the theorem? The net torque about any point of a system of forces is equal to the torque about the same point due to the resultant force. Okay. You can take a screenshot. Okay, so let's move on to the next one, B. Two forces are in opposite direction. Okay, so now two forces are in opposite direction. Now let's try to find the line of action of the result. Okay, so now here this is F1 and this is F2. Let's say the magnitude of F1 is greater than the magnitude of F2. Okay, simply I can say this F1 is greater than F2. Okay, so then we know the result, the magnitude of the resultant, the magnitude of the resultant. So R I take as the magnitude of the resultant. So it will be in the direction of the larger force. So it is F1 minus F2. So R equals F1 minus F2. And the direction is in the direction of F1. The direction is in the direction of larger force. F1 larger force. Okay, so now we know how to find the magnitude of the resultant and also the direction. So now we want to find the line of action. All right, so here I'll mark the resultant. So, by the way, in the previous one, I forgot to mention one thing. Okay, I'll say that. So this is the previous one, the case A, both the forces are in the same direction. So here, by taking xy distance, we know the relative position of the r. So the only thing that I want to tell you is this resultant will be in this region. It is confined between the two forces. It cannot go here, this side or this side. So the magnitude of the resultant will be varying in this region. If the two forces are equal, it will be. If this force is very large, let's say this one is 10,000 newtons and the right side one is 0.001 newtons. So this one will be very close to this one, but it will be very equal to this when this force is equal to 0. If you take this force, then the resultant equals to that. That's very clear. Now, if only one force is acting, that will be the resultant. Okay, right. So take a පැහැදිලිනේ හැමෝටම. Right. So now the second case. Now here let's assume this is the line of action, and I consider this is the resultant. Okay, I consider here a point A. So I'll take the moment about point A. So this is, let's say, x, and this distance y. So taking the moment about point A, f1 times x, and then plus f2 times y equals to r times 0. So then we get f1x plus 2y equal to 0. f1 equals to f1 is equals to, sorry, f1 times x equals to minus f2 times y. Since we are dealing with the distances, so I take this x equals to minus f2 over f1 times y, right? So which tells us if you measure x from a particular point in this direction, then y will be in the other direction. Yeah, no, something, wait. Hold on, something is missing. So here we get f1x is equals to 2 times y. Give me a second. Okay, so here actually we get this. Okay, so this is the x equals minus f2 f1 times y. Okay, I'll explain with you an example. So here, for example, let's say f1 example, f1 is equals to, let's say, 20 Newton, and f2 is equals 10 Newton. Then we get x equals minus 20 over 10 into y. So x equals minus 2 times y, right? Okay, so here x, this will be actually the line of action of the resultant will be outside the larger force. Here we had to, if I say f1 is greater than, we have considered f1 is greater, so the line of action of the resultant will be outside the f1 force. Okay. So the resultant will be somewhere here, this side, in this direction. Okay. Yes. Okay, so here the resultant will be here. Okay, wait, give me a second. Yeah, so I'll consider writing this equation by thinking that R is here. So if I write the equation from here, then let's say this point is B. So from the point B, I'll take the moment. Okay, so let's say this distance is X and this is Y. So then if I take the moment, then we have if F2 is making clockwise, so we have F2 times Y minus F1 times X equals to 0. Okay. Okay, so I can explain you like this. Now here we have considering the magnitudes F1 and F2. Okay. If I consider in the previous way, from taking from A. So here length cannot be negative, right? So here you are getting a negative value. A length cannot be negative. So therefore, if I take this here, you can't find solutions. Okay. X and Y cannot be negative. Yeah, that's how we argue, yes. Okay, so here one of the length is negative, right? So therefore we can solve the system. Therefore, we can say the resultant cannot lie here. So now we can take to the point B and then we can write, then now we have F2 into Y equals F1 into X, right? Because according to the sum theorem of that moment, the net torque about the resultant is equals to the moment about the resultant is equal to the net torque of the sum of the moments, right? So if you take here, then this f1x and f2y cannot equal to 0, right? Or else you are getting here for a length negative answer. So which is not true, this contradicts. So therefore, now I can consider a point B, then we can solve it. Okay. Since here also we can argue that the force should be outside the larger force, because then only we get this. Now, if we get f2y minus f1x should be equal to 0 now. So if 2 is large means this one has to be smaller. Okay, and then right. So f1, because this product should equals to this product. If 2y should equals to f1x. So if 2 is larger than f1 means y is smaller than x. Therefore, if you take that in this side, it won't happen, right? Then according to the lens, it will true only if it's in this direction. Did you understand? So first you can write this and we can say this contradicts, because a length cannot be a negative. Okay. And then therefore we can argue this. Now if you take the moment from this point somewhere here, for example, let's say, then you will get f3 times the small distance. So f3 is small number. For example, okay, it will be very easy if you put the values here, 20 and this is 10. Okay, so if you take from this point 20 into larger distance and then 10 into small distance, can it be balanced? No. To balance that, this force has to be in this direction. Do you all understand? Hirosh, Sufar and Abhiushani? Okay. So when two forces are in opposite direction, when two forces are in opposite direction, 3 points. The resultant will be in the which results, the magnitude of the resultant can be found by taking the difference between the two forces. Let's say 20 and 10, 20 minus 10, 10 newtons. And the direction will be in the direction of the larger force, and the line of action will be outside the outside to the larger force. Okay. Please take down notes. Okay. Take a screenshot. I'll clear this. I'll explain again quickly. So if the two forces are in opposite directions, okay, so two forces are acting in opposite directions. Let's say F1 and F2. We take F1 is greater than F2, then the resultant will be R equals F1 minus F2 and its direction in the direction of F1. Now if you take this theory, I mean the sigma F5 di is equals to R times d. The net torque about any point for system of forces is equal to the movement of force by the resultant from that same point. Okay, sigma Fi di equals to R times d. Okay, I hope you all can understand this. If not, please let me know. Okay, so if you take now if I taking the line of action, if I taking the movement considering this, the R times d, okay, so if I take that, let's say if the line of action is here, okay, and if you take the moment about this point A, okay, so if you take about A, R into 0, that is 0, but the other one, the sigma phi di is equals to, now here this length, let's say A, and this is B, for example. So F1 times A, this is also plus moment, this is also plus moment. F2 times B. So can that be happen? Both are making a clockwise movement. So this is not equal to 0. So this contradicts this theorem. That is fundamental. So therefore, which is cannot be correct. But if you take this here, okay, then what it says, if you take that there, let's say point B, here point A, and then if you take from point B, here small force, F2 is small. Small force into small distance is equals to large force into larger distance. That is also cannot be correct. You are saying 2 into 3 is equals to 7 into 12. Can it be true? No. Therefore, it also won't be correct. So therefore, the line of action, the resultant will be here outside the larger force. Is that clear, everyone? Okay. Okay, and then two equal forces in opposite directions. Now, two equal forces in opposite directions, then what would happen? Okay, so with now another 2 minutes, we'll finish with this. Finish. Yeah, presentation is over. So this is the last theory. Now two forces, two equal forces in opposite direction, that is the force couple. So no resultant, but there will be a movement F times the distance between them. Okay. So this is the movement. So here no resultant, right? The line of action of resultant, where if there is no resultant, from where, in which world we can find the resultant, the line of action. So here resultant is 0, so therefore no resultant force, so therefore no line of action, but there is a non-zero moment Fd, right? Okay, so with this the theory parts are all over regarding the moment of force. So you have to do questions. I'll send you some questions. Also, you also can find some past paper questions and all. Okay, and if you find anything difficult and you need to have some explanation, you can share it to the group. Yeah, I prefer sharing it to the group so others also see that they also give a try for that question. Yeah, okay then. So that's all for today. Probably most of you are yawning. No, you won't be yawning during my class, isn't it, right? Okay then, bye, good night, sweet dreams. Take care.